Hey everybody, welcome to today's webinar on getting to machine learning with MariaDB SkySQL and MindsDB. We have an informative session for you today, led by Jags Ramnarayan, who is a GM of SkySQL, hey Jags, at MariaDB, and also Jorge Torres, who is the CEO of MindsDB. Before we get started, a few quick housekeeping items. Our timing for today is going to, for the content and the live demo, is going to run about 40 to 45 minutes, and we've got 15 minutes at the end for Q&A. We are recording this. We'll provide a link and a copy of the presentation after the recording is finished. And you'll notice in the platform that we're using, feel free to use the chat to introduce yourself, ask questions in the Q&A window, and you can interact via the emojis with a react button during the presentation. All right, so without further ado, let me hand over to Jags.
Yeah, thank you. Thank you, Dave. Hello, everybody. First of all, thanks a lot for taking the time to attend a session. So let me just jump right into it with the problem statement. I think a lot of you probably come from a bit of the machine learning background. And the single most challenging thing in machine learning today is how do you make it simple enough so that an average developer who is building apps, which is getting built on an unprecedented rate, can literally use AutoML and can become productive building essentially AI apps. Colloquially, it is known as sort of how do we democratize essentially machine learning development itself. Here's a slide I stole from a project called Dawn within Stanford, where the primary mission behind the project is all about how do we democratize, essentially, how do we make things much more simpler. And what you find, okay, thank you. What you find in this slide, which is interesting, is that very little time, not very unsurprisingly, goes into actual development of machine learning code, and it goes, everything around it is where the time gets spent. How do we get to the right data sources? Do I have the right quality of data? How do I essentially turn that data, shape it so that it gets converted into features? How do I encode? How do I verify the data is good? Significant volume, weeks, maybe months get spent, time gets spent on this. What is also interesting in this slide is that a lot of time gets spent in things like, well, how do I now scale it? How do I go for machine resource management? How do I monitor? How do I serve these so that the entire pipeline of model ops is also relatively simple, it is secure, and you can actually trust your models, right? So now the theme of today's talk is all about in-database machine learning. Is there a way we can essentially take a fairly robust, rich, scalable SQL database and bring the machine learning component to sit on top of it and as a fuse it together, right? So that it now becomes a lot more easier. Now let's look at some of those elements. As an example, if say we were to do data access, if my data is already in my database, right? It's either in tables or for instance, even if it's external, most of the databases today offers things like external tables, right? So I can connect to an S3 bucket and essentially can infer schemas and things like that, right? So I can get access to my data right away, so I don't have to worry about connectivity, I don't have to worry about parallelism, I don't have to worry about security, those kinds of aspects. Now, if you all think about it, a lot of the other elements, right? This whole data wrangling, how do I transform data? How do I validate? How do I make sure that data is essentially integrity is maintained? All of that, a SQL database is really good at doing, right? You can build complex if-then-else logic in SQL statements. Not only that, the biggest thing for me is when you're doing complex ETL and the data is in fact large, you don't have to worry about optimizing things, right? SQL engines are really greatly well built to kind of create a logical plan, and it turns it into a physical plan with an optimizer and does it really, really well, right? Not only that, I mean, you can even do things like imputing data, right? Where you're taking essentially data that's impure, maybe it's full of holes, and you can impute it so that now you're filling up the holes with some content that can in turn be making it easy for you to do essentially feature engineering, right? On top of that, from a model accuracy standpoint, if my machine learning system where I'm training data is sort of built along with the database that's, let's say, operational in nature. In other words, it is the one that is continuously consuming the real-time data from my applications. Now, perhaps if the database is also scalable, then I can actually turn around and produce some models much more quickly. I can iterate and retrain my models relatively quickly. especially if there are sort of, addressing the model drift kind of challenges, right? So that the model accuracy and the efficacy of the models is much better also. And the final few points, if the database and the machine learning system were sort of coupled together, it'll probably be a lot easier for the generated model to get deployed back into the database so that predictions and scoring can also happen in real time. So essentially the main takeaway, guys, for this talk is that our belief is that instead of you essentially using 5 different Python libraries, packages, worrying about multidimensional vectors, worrying about feature engineering and still working with databases, what if we were to take AutoML, which is what MindsDB can do really, really well, along with essentially a flavor of doing all this using SQL, and all of a sudden what you find is that you become a lot more productive. And to us, that is a true democratization of machine learning development, if you may. Okay. So I got to do this customary marketing of MariaDB, and I'll introduce essentially what we do, right? So I think MariaDB, for most of you, I'm assuming you already are familiar with who MariaDB is. It's in the database circles, it's a household name. We're the fastest growing one of the most popular open source databases in the world, right? About 75% of all Fortune 500 customers use us. We have well over north of 1 billion Docker downloads. We are in the top 5 databases in the Docker Hub. Now, most of you probably recognize MariaDB as the OLTP database, which is sort of in some sense the successor of MySQL to many folks out there. But also there are a number of other things you do. The main thing is that one of the things we've introduced lately in the last 2 years is SkySQL, a full-fledged DBaaS, which I'll talk about in a second. But we also offer things like analytics that is built into MariaDB, especially in SkySQL. And we also offer a distributed, highly scalable, linearly scalable database called Expand. Okay. As I said, we are in pretty much in every single vertical right now, with hundreds and hundreds of customers that essentially run MariaDB in production for mission critical application workloads, right? So what is SkySQL? In a nutshell, SkySQL is a fully managed cloud DBaaS platform. It has a number of distinction characteristics than what you would find with, let's say, Amazon or the big hyperscalers, which I'll touch on in a second. But again, to just repeat that same point, that it's not just MariaDB is not just about OLTP. We can essentially do highly scalable OLTP. We can do mixed workloads and analytics really well inside SkySQL as a managed single platform. You can just get started with SkySQL today. We offer $500 free credit, which goes a long way, right? And here is a URL that takes you there, right? So how is it that we are fundamentally different than the hyperscalers, the big, Amazons, the Googles or Microsofts of the world? So if you start thinking about how modern day apps are getting built, a lot of the apps are really SaaS, right? You sort of start off with simple microservices, and over time they become complex. And quite often what we find is that there is tremendous infrastructure sprawl. You might start with a microservice starts with a little MySQL RDS instance. Very quickly it finds out saying, hey, I need some NoSQL going on. So I put together a document database, another microservice uses it. And all of a sudden I have to join the two together. I have no choice but to pipeline the data and maybe into a Redshift. All of a sudden you go from a MySQL-like dialect to a Postgres-like dialect, let alone the fact that I have to write that complex pipeline. Maybe I need to speed up my query processing. I put together a caching system. What you find is that all of these are disparate API-based systems, different products altogether. There's no uniformity, and the developers have to suffer through all that. So our premise is a little bit different, right? We think that what is really required is an architectural approach where you can start small, and then be able to scale. If my demands of my app grows and changes, I should be able to scale. If I want NoSQL within that same system, if you may, I should be able to do NoSQL or add analytics. We do believe that purpose-built databases are the right thing, right? In other words, purpose-built engines for analytics, for OLTP, for mixed workloads have to be distinct, but they don't have to be presented at completely as different things to the developer, right? It could absolutely offer a uniform API, a uniform configuration model, that sort of thing, right? Making it a lot simpler for, if you may, the average developer to get going. And that's the basic premise of SkySQL. This is an animated slide, but I don't have animations right now going on here. So let me just briefly cover what SkySQL is. So like I said before, the most often when folks come to MariaDB, they're essentially either running MySQL, Oracle, maybe Sybase, or of course MariaDB community server itself. And with a few clicks, a few commands, you can immediately start running with our enterprise server offering, right? So it's very easy to migrate. You kind of start small. You start saying that, hey, I need more and more readers that are coming in. You can add read replicas on the fly. You can dynamically scale. But the more interesting thing is that not only can we do what MariaDB and MySQL can do well, but now all of a sudden, if you start to see workloads changing, as an example, specifically in the conversation we're having, what if I want to do AI? Or to predictability to let's say to offer, let's say, the next best offer, or to understand customer behavior for that matter. All of a sudden I have to track every single customer activity, and massive data growth is happening. The write rates are exploding in nature. So that's where we have a way to sort of say, like, hey, can you go from a much more centralized read replica based design to a highly scalable distributed SQL design, where every node is sort of equivalent. You can dramatically scale on writes. All replicas are 100% consistent. And with Expand, which is our sort of marquee offering here, not only can you do that, we can actually replicate the data across global regions, right? So you can essentially have global visibility to your data also with advances. And finally, we also support columnar data management within Expand. So essentially, it's a very modern sort of hyper scalable database, which can serve not just OLTP really well, but also do analytics on top of that too. And finally, we have column store, which says, hey, if your data volumes are really warehouse scale, right? All of a sudden you have massive scales, massive volumes of data you're accumulating. You can essentially take your historical data, migrate into column store, which essentially manages the data in the modern, if you may, data warehouse, which is nothing but your cloud storage, S3, GCS, your Azure blob stores, if you may. And all of a sudden you can get analytics on top of it too. So I'm not going to go through all the rest of it. There's a number of other capabilities. So for instance, caching is built into max scale. So you don't have to leave from one system to the next, unlike the hyperscalers. All of this is unified and offered to you as a single offering, right? So the key point here I'm trying to make is the following, right? That even though we do believe, again, in sort of different engines that you need for different workloads, the dialect, the SQL dialect that you work with is the same, right? You just stick with MariaDB dialect or the MySQL dialect. Doesn't matter what kind of workloads you're working with. And that's a huge power of sort of SkySQL, if you may. Okay. So finally, just bring it together with sort of MindsDB, which we're very, very thrilled about, right? Because MindsDB, again, goes with that same flavor of thinking that you're essentially doing AI, building AI-based applications with a SQL-based sort of philosophy, right? So MindsDB sits on top of essentially SkySQL. Your apps come in and running SQL directly on, so let's say you're doing exploration, you can directly do it on sort of SkySQL. And of course, if you want to like sort of train your models, I don't want to steal the thunder from Jorge, which will cover how you can build out your predictors to train your models just using SQL. And likewise, if you're actually doing scoring or predictions, you essentially do SQL on top of it. So it comes down to like you do SQL, a single SQL dialect for OLTP, OLAP, or mixed workload. And the same dialect, by the way, if I'm not mistaken, MindsDB's dialect, the primary dialect that they offer, is also based on MySQL, right? So you do the same SQL-like thing for training and for predictions. So that was my quick rant on what it is. So I'm just going to hand it off to Jorge. Thank you, guys.
Thank you, Yax. That was fantastic. And we're very excited about the journey that we've been walking with MariaDB since the very beginning. And there's still so much that we have planned for the future. But the interesting thing is that now anyone can get the value of both, SkySQL, MariaDB, and MindsDB. It works. And it works because of that abstraction of being able to treat everything in SQL. Let me start my slides. Sorry. Allergies. MindsDB started as an open source project at UC Berkeley. We started it in December 2017 by myself and my co-founder, Adam Carrigan. We've got $7.8 million in seed funding. And the idea of that seed funding was to turn the idea of being able to do machine learning in the same flow that people have data and in the same data layer to our reality. And of course, the challenges and the value that we provide for the customer is that, we want to simplify the journey from you want to do machine learning to you actually being able to do machine learning. And the idea is that you can do all of this in the same speed that you can actually transform and treat data at the database. And that's exactly what we're bringing to the table. So democratizing machine learning is the name of the game for us. And kind of like what Yagas was describing, there are these different blocks around machine learning. And if you were to see them not in terms of complexity, but in terms of the life cycle, you have the data preparation, the modeling, and the deployment. And we truly believe that this first part, the data preparation and the modeling, can be disrupted and is disrupted by MindsDB. And many people that start in the journey of machine learning, they start similar to how they learn machine learning when they're doing their PhD thesis or when they're learning through Coursera. And this is not necessarily the way that you should tackle an applied machine learning problem. So let me describe this a little bit. If your data is already in a database, it doesn't make sense for you to try to do data transformations elsewhere, to try to do Jupyter notebooks, or to try to do it in the way that most data science classes will teach you. Databases already provide the right framework for this. Sorry, I need to sneeze. I apologize. Allergy season. So being able to do all of this in SQL is actually the biggest simplification that you can do to the ML lifecycle. If you can write a query, and if your data is already in the database, then you're already dealing with most of the most difficult problem, which is data acquisition, data cleaning, feature engineering, all of that MariaDB can do for you. And then the idea that we had is, can we simplify the second step, which is the modeling, in a way that it feels very natural for someone that has already been doing the data preparation at the database layer. And to look at this, let's kind of actually jump into some problem overview, and actually we can then summarize what MindsDB provides for you, and then we can jump into an example. So the idea of data preparation in SQL is natural for anyone here, hopefully. And SQL is the right dialect to do data transformation, feature engineering. At the end, after a query, what you have is a table, and those columns are features. And you can essentially clean them and do whatever you need to do, because SQL dialect allows you to do transformations in a declarative approach. So this part is covered. The next part is, okay, can we actually do machine learning in SQL? So to summarize this idea, let's start with a very simple example. Imagine that you have a table, income and debt. And if you were to visualize this table, you have what you have on the right-hand side. Now, databases are designed to give you answers when you actually have a word statement that matches an index or matches some records. However, they're not designed to give you an approximation. Yeah? Now, anyone that has done a machine learning model understands that you can actually build a hyperplane or a line that fits the data that you have. And the concept behind MindsDB is, let's create a syntax that is very similar to that of creating a view, so that you can actually create that line and train that line, fit that line to the data that you have in the database, but in a way that feels very natural for any SQL user. Now, the next part is, can you query this line the same way that you query a table? And what I'm trying to describe here is, the beauty of MindsDB is that the abstraction is the same as if you had a table, even though when you're querying this line, depending on the input, you're getting a response, or you're getting an approximation. And this idea can extend to very complex machine learning models. Of course, most data and databases doesn't include just 2 columns and just a few rows. They're like multivariate, and they tend to be very complex. But MindsDB allows you to bring the state-of-the-art of machine learning to solve this type of questions. So the idea behind database and machine learning as tables really simplifies the journey. I believe that once we bring this capability, then you're thinking of model deployment the same way as you're thinking of deploying a table, which is essentially, as soon as you do create predictor statement, that is already deployed. So you're not actually dissecting this into different stages, you're treating it all within the same layer. Okay, let's jump into a demo. So in this demo, we're going to actually do something a little bit more complex than that example. I just wanted to convey it in a way that was very simple, and then we can start kind of like dialing up the complexity in terms of the machine learning complexity, but the syntax remains the same. So as Yax was describing, MindsDB is compatible from the beginning and from design with MySQL databases and with MariaDB. And the dialect is very similar when it comes to the additions that we have to machine learning. Yet, when you create a model, it's the same thing. You actually query it as opposed to table. Now, there is this abstraction, which is databases. MindsDB is not a database in itself, but is this layer on top of databases. And therefore, you can bring in or connect databases with the create database statements. And this is how it goes. We're going to connect to SkySQL. And with this connection, you can now actually see the databases that we have connected. So there is the SkySQL one. Now, we're going to actually query the database for some information that is already in this database. So here we have a very simple example: number of rooms, number of bathrooms, square footage, location. As you can see, this is a little bit more complex than the example that we showed before. But the objective here is to be able to forecast the rental price given information that we have at a new property, trying to minimize the number of days in the market. So what we're going to do here is we're going to run the create predictor statement. And what this does is, okay, I want to create a predictor using the connection that I have, SkySQL version 2, and learning from all the table that I just showed you, and I want to predict the rental price column. Once you do that, you can actually check for the actual predictors that are trained. So let's see the status. This one is training. It will take a few minutes. Now, the interesting part about MindsDB is that these models are being created in a way that you can declare them and let the AutoML do all the magic, or you can specify how you want this model to be created. I'll jump in a little bit into the actual details of this, but let's actually check and see if this actually finished. Still training. Just bear with us a few seconds. Right. This will take a few minutes or a few more seconds to train. But while we do this, let me walk you into some of the things that are happening behind the scenes. MindsDB looks at this table, the one that we have for training the predictor, and actually analyzes each column and analyzes what data type it has. And then it goes and takes the state of the art for encoding this information. So most of this information is numerical, but here's like a categorical feature. You don't have to actually specify, if you don't want to, how you want to encode this data. But MindsDB then goes and checks, okay, what is the actual distribution that this data has? And let me create like a one hot vector encoding for this. It does the same thing for the neighborhood. And then it tries to understand how to combine all of that information so it can get into the rental price. By default, MindsDB tries a few different things, and it chooses the best model for that. Let's see if we're done with the training phase. Okay, still training. Let me actually try a different predictor that's already been trained. Okay, let's go for this one in the meantime, so I can describe it. Okay, I have another model trained while this one is training, but what MindsDB does is that it understands as well that for this type of problem, the one that you want to do the prediction for rental price is going to choose an accuracy function, which is called the R-squared function. And for this one, it gets a 99% accuracy. And then it just gives you a summary of what it did to train the model. Actually, if you want to see what the model is like, you can go and type how you want to visualize the ensemble. Yeah, and then you can see what I was describing to you. It goes and looks into each of the columns, it analyzes what type of encoder it will use. And then at the end, it'll try to pick a few different models. So in this one, it's telling, let me choose the best of the different neural network, like GBM, regression, and actually try them all. And then if you see the actual description of what happened after it finished training, you can see what of all those models it picks. So it tried the neural network, like GBM regression, and actually the one that performs the best is like GBM. So the model for predicting this particular renter prices is going to be that one. Now let's see if our actual model finished training. Yeah, it's done. Okay, so now that it's done, we can go back into understanding what the model was for this one that we trained. It picked light GBM again, same accuracy. And once that is done, your model is already deployed. It's already being able to, or you can consume this model the same way that you can consume a table. So let's actually make a query to that model. Okay, so now it's telling me for a property that has a square footage of 823, in a location that is good, neighborhood good, downtown, and the days of market that I want to be no longer than 10 days, this property will rent for 1,200. Now, MindsDB allows you to do things that are even more natural. I mean, querying a table is very natural, but things that are natural to a database that are not easy to do when you're actually having a model outside of the data layer, which is you can join this model with tables that you have. So let's actually make a join with the actual data that we trained so we can see the real versus trained value. And as you can see, what MindsDB does is that now it treats this model as if it was a table and leverages on all the capabilities that databases have, such as joining tables together. And you can now compare, what is the real price versus the predicted price, face value. And you can see how off is it when it comes to predictions. And it's actually getting really good results. Now, what I wanted to get back into is, let's get back into the slides, is that this life cycle all of a sudden gets super simplified. You have the idea of preparation at the data layer and preparation with SkySQL. And then you have the modeling in a way that is very similar and natural to that of using any machine learning table as or any machine learning model as a table is the same as using a view or a table in itself. And then deployment is something that is natural because it's the same concept of creating a table or a view. Once it's done, it's ready for you to consume it, and it's ready for you to actually combine that information with data that you have in the layer. So you've simplified by combining MariaDB plus MindsDB, all of the machine learning lifecycle into simple steps that are natural to any SQL user or SQL user. Now, eliminating this complexity brings a lot of things to the table. No data latency for models. That means, of course, there is data that is being behind the scenes moved around behind MindsDB and MariaDB. But at the end, the amount of data that you need to move for inference is so low that the latency is almost insignificant. Then you can actually scale this quite a lot because MindsDB doesn't hog resources from your MariaDB infrastructure or your SkySQL infrastructure. It only queries for training. And then when you're actually doing the prediction, the predictions run in a different kind of cluster environment, which is specialized for machine learning. And then the last part is extensibility. MindsDB allows you to extend your capabilities down to the different capabilities that you may actually need in terms of machine learning. We integrate with many other machine learning frameworks other than the OML that we provide. Yax?
I guess, this is just Dave's slide.
Yeah, so thanks everyone for attending. We got through that content fairly quickly today. We got through that in 30 minutes. One of the things I would like to just mention, there's been a few questions that we'll get to in a second, but I wanted to make sure that everyone is aware that there is a free MariaDB cloud database available. If you actually go to cloud.mariadb.com/SkySQL, you can actually see where you can sign up there. There is a promotion that they're running at the moment. And then we also have a free MindsDB account that you can sign up for. And we also would request for those people that are working working with our community if you wanted to give us a star on GitHub. What I'll do now is we've got a few more minutes, and so I'm going to take a couple of questions. If you do have a question and you've been putting it in the chat, if you could put it into the Q&A section, we can then work through each of the questions as they come up. And so I see, let me see, let's look at the questions at the moment. So there's a question here. What libraries are under the hood of the models, and can I bring my own?
Yes. So MindsDB uses PyTorch behind the scenes for its AutoML. And then it brings others to the mix, such as LightGBM and various kind of like AutoML frameworks that you don't have to deploy yourself. Now, if you actually want to specify how the building blocks of your model have to be built in a declarative approach, MindsDB provides a library called Lightwood, which is a declarative approach to machine learning. Then on the other hand, if you have your own machine learning models already, and you already have infrastructure to serve those models, but not necessarily at the data layer, such as MLflow, MindsDB integrates seamlessly with MLflow, RayServe. And that way, even the models that you've already produced yourself, you can now expose them as if they were tables. You can even train them from data that exists in your MariaDB database, and you can now start using these applications that consume data from the database using the MySQL Wire protocol, such as BA tools, etc. So what we're trying to describe here is MindsDB starts with an AutoML feature that you can use, but then allows you to expand this in a way that you can declare the components that you have, and that is Lightwood as a framework. And then if you have your own models, MindsDB allows you to seamlessly integrate those models as if they were tables in the data layer. And the frameworks that we support for that are MLflow and RayServe.
Great. There's another question. I think this one's in the chat, but is it possible to set in MindsDB ML supervised, unsupervised, and reinforced learning depending on the data and models required to implement?
Yeah, that is a great question. So MindsDB right now focuses only on supervised and semi-supervised. Unsupervised learning is not yet one of the things that we do. Yet, depending on how you want to see this, because MindsDB can be used for, say, anomaly detection, and it has like training on the loop. So there are some behaviors that are reinforced learning, like in MindsDB for this type of use cases, especially when you want to do, constant machine learning over streams of data. But the bread and butter of MindsDB so far is supervised learning, where you have some data and you have this data in your database. This data likely is already labeled, and you actually want to forecast one of the columns or a few of the columns that you have after a table or a query.
Okay, we've got another question in the chat here, which is how fast is the inference through SQL comparing to interfaces using other tools on the market via an API? Is there a performance cost for using in SQL ML?
Yeah, so there's always, every time you add like a new addition to your cake of data, there's going to be some delta on the latency. Yet, what is important for us to describe here is that delta we're talking about, sub-milliseconds, depending on how complex your model is, and at the end, it's limited by how much data you're piping into the model and how much computational complexity there is behind your model. But for most data that exists on databases today, production databases where you have columns that have numbers and categories, these models are very, very quick. And therefore, the latency is, again, sub-milliseconds. Now, on the other hand, if you have complex data types, say long text, you may have books and the reviews of the book, then this task may take a little bit more. But we're still talking about like tens of milliseconds. And the worst case scenario, hundreds of milliseconds. The idea behind MindsDB is that these resources are not being hogged from the database. So all the computational effort for the machine learning part runs on the MindsDB server, and then MariaDB is serving the actual data for the model. Moving data from MariaDB to MindsDB at training time, yes, that may take some time, but training is something that you don't do that frequent. You may do at most like every hour. Most people do it every month, depending on what you consider your data drift to be. But then on the other hand, inference, you only require the information for the row that you're trying to forecast. And therefore, that move of data from MindsDB or from MariaDB to MindsDB, you're not essentially moving that much data. It's the same as when you query a table from a client. Hope that answers the question. But the game here is optimize resources by enabling the database to do what it's meant to do, which is data transformations and actually proper kind of, as kind of Yax was describing, that they have like a proper plan to execute in the most optimal way, depending on the query that you have. And then for MindsDB to handle the machine learning part in a way that is natural for the database user. Now, on the other hand, when you have this workflow, say, running behind an API, a RESTful API, the latency there as well has to do with the complexity of the model. I mean, yes, there is session handling and whatnot of whatever protocol you have for serving your model, but most of the latency comes into how complex your model is. The difficulty is if that is behind the RESTful API, say, for instance, how are you going to query that model from, say, a tool like Tableau or from an application that already speaks to MySQL? That is the simplification that we bring into the table. And therefore, even if your model is behind the RESTful API, MindsDB can create the abstraction so that you can now query this at the data layer and then do a few things: train or retrain that model from data that is in your SkySQL server, and even join and enrich data that may be in your SkySQL server with very simple SQL statements. So I encourage you to go visit the documentation that we have for how to do this all in SQL, as well as the documentation that we have for doing this with MariaDB.
Hey, Jorge, just as a follow-on thought here, you mentioned inference, right? Now, presumably it's also possible to use, let's say, SQL functions. Your OLTP app is just running SQL, and you can use functions to essentially call out, let's say, using the connect engine into MindsDB, passing the row, doing the prediction, kind of keeping it even transparent even there, right? Presumably that's possible too.
Yeah, that is possible. And it's interesting you bring the connect engine, because since this, and for all sakes and purposes, MindsDB looks like either a MariaDB MySQL server, you can use the connect engine, and then the tables that you have as models, or the models as tables, can be queried as external tables in MariaDB. And then we have this ability of also creating views. So essentially, if you want to join a table with a model, you can also bring those back to MariaDB. So you don't even have to call them as functions. You can still treat them as this kind of first-class citizen kind of data abstraction, which is a table or a view, back into the MariaDB stage.
We have a couple more questions in the chat. One that's sort of related to that you were talking about is, can I train a model from multiple sources or multiple databases? So, for example, if I have something on-prem and in SkySQL.
Yeah. So MindsDB allows you to connect to multiple databases. Say, for instance, you have like something on premise, and then you have SkySQL, and you need to join these two together. That's something that you can do. You can create views internally within MindsDB. For more complex and diverse data sources, say, for instance, you have something in MariaDB and you have some other information behind S3, and you don't want to kind of ETL that back into MariaDB. We integrate with tools like Trino that allow you to then plug Trino to your SkySQL and then all the data sources, and then join them and then train the model there. The flexibility of MindsDB is that at the end, we don't run the compute for those queries. So if your underlying database supports a query, then we pass that on. The only thing that MindsDB does to facilitate things is to be able to join information that you connect to MindsDB, or connect different tables and then join them, so long that join is very simple. If that is more complex, then we encourage people to try something like Trino.
Yeah, I mean, just to add to that, Jorge, now SkySQL also offers similar capabilities, right? So you can essentially use our column store capability And that can just work with storage. For instance, you have data sets in S3 and stuff like that. You can literally just sit there, capitalize on the dynamic parallelism and dynamic scale that we offer in the SkySQL to be able to do in those complex joins, complex aggregations, prepare the data sets relatively easily. So many options exist also just through SkySQL also.
And that's a fantastic point, Jax, because it's reinforcing the idea that right now, if you have a problem with data preparation, it is likely that it's solved already by the database, or that is in the roadmap of being solved by the database. And again, you guys at MariaDB have been building databases for a long time. Like even before you built one of the most the second most popular one, MySQL, and then took all the learnings into MariaDB so that MariaDB can kind of even expand that broader. And all those years of experience are kind of shouldn't be ignored. So if you have a problem that involves data preparation, it is best to try to see and the database can do it for you, either SkySQL or MariaDB, and likely you will find the answer. So the one learning that I think is important for anyone to walk out of this conversation from or with is that databases are so powerful for the most important piece of the puzzle of machine learning, which is data preparation, that if you can avoid trying to do all of this in PyTorch and try to do all of this in kind of Jupyter notebooks, etc., you're going to save yourself a great deal of adventure, if you may, when it comes to deploying models into production, because you're relying now on infrastructure that has been proven to work, which is MariaDB. Then on the other hand, MindsDB can leverage on that capability so that end to end you can produce machine learning with this amount of steps.
All right, a couple more questions in the chat or in the Q&A section we have here. There's another one here. What about NLP? Does MindsDB have a solution for this?
Yeah, so we support columns that are text, and for those, you can have target variables that are also text that is being generated. The idea behind MindsDB is to support data types and problems that are common at the data layer. So again, classification, regression tend to be those. Again, if you want to classify something given some text, that still is an NLP task, and MindsDB supports it well. One of the things that we're doing right now is we're bringing integrations to other frameworks like Hugging Face. If you guys are interested, we can give you early access to this, so you can do and run any of the NLP model that exists in the Hugging Face ecosystem, combined with the data that you may have in MariaDB.
And that's actually probably a fantastic segue into next steps for the webinar. So on behalf of everyone that attended, thank you so much, Jax and Jorge, for presenting today. What we'll do is we'll wind that up. As a next step, if you did want to have additional questions, please head over to the MindsDB community Slack. We will be doing an office hours at some point to answer any other questions. And we'd like to thank you so much for your attendance today.
Thank you, everybody. Thanks, Dave.